All right, today we're going on a bit of a journey. We're going to dig deep, and I mean literally dig deep, to really get the story of our home, planet Earth. We're going to explore how it all works, from its fiery center all the way out to the air we breathe. You know, what I love about this is that the story isn't written down in some old book. It's written in the rocks, the oceans, the air, the planet itself. I'm really excited to figure out how all these huge, complicated pieces of the puzzle actually fit together to make this one place in the universe that we know can support life.
So, to get started, let's just take a moment with this idea right here. I want you to imagine a round, blue ball floating in the dark. That's the famous blue marble photo, isn't it? From the Apollo 17 mission. You know, that single picture completely changed how we saw ourselves, didn't it? For the first time, we saw our home not as this endless world, but as this small, delicate sphere. It looks so alone out there.
It does, and from that distance, it looks so simple, so peaceful. But, like we're asking here, that simple blue and white surface is hiding an unbelievable amount of complexity.
Right. And that really gets to the big question for today, doesn't it? What is actually going on inside that blue marble? What's the invisible machinery that makes our planet work?
To get that answer, we've got to peel back the layers. And we're going to start with two shields that we can't even see, two protective layers that make all life on Earth possible. The atmosphere high above us, and the super hot core deep, deep beneath our feet. So let's start with the atmosphere. I think the best way to think about it, like it says here, is as a giant invisible blanket made of gas that's wrapped all around the Earth. It's mostly nitrogen and oxygen, and its main job is to trap just the right amount of heat from the sun. A planetary blanket, that's a really good way to put it. It sounds kind of cozy, but I'm guessing it does a lot more than just keep things warm.
Oh, it does so much more. This slide really shows you what's at stake. Without that blanket, Earth would be a lot more like the moon. We're talking scorching hot in the daytime and then plunging to unbelievably cold at night. Our atmosphere evens all that out. It protects us from nasty solar radiation, and, well, it gives us the air we breathe. Wow. So it's basically the ultimate life support system. Without it, none of this, none of us could possibly be here.
Okay, so that's the protective layer on the outside. But what about the inside? I've always wondered about this. I mean, we can't see through the ground. We've never drilled down that far. So how in the world do we know what's actually deep inside the Earth?
That is a great question. It's the biggest challenge in geology, and the answer is pretty amazing. Scientists figured out how to listen to the Earth. They study the powerful energy waves that travel through the planet after an earthquake. These are called seismic waves. So it's not actually sound they're listening to, but they're tracking how these waves of energy move. It's almost like giving the entire planet an ultrasound.
That is the perfect analogy. It's exactly like an ultrasound. By watching how those waves speed up, slow down, bend, or bounce, they've been able to map out this entire inner structure. So, we're living up here on the crust, which is super thin, like the skin in an apple. Under that, you've got the mantle, this huge layer of hot rock that flows, but incredibly slowly. And then right in the middle, you have the core. And the core has two parts, right? A liquid outer core and then a solid inner core. It just blows my mind to think there's a solid ball of metal as hot as the surface of the sun spinning around right in the center of our world.
It's pretty wild. And that liquid outer core is so important for another reason. All that moving liquid iron swirling around the solid inner core, it acts like a giant dynamo, a huge electric generator. And this process creates a massive magnetic field that wraps around the entire planet.
Right, and that magnetic field is our other invisible shield, isn't it?
I've heard it's what protects us from something called the solar wind. You got it. It's our planetary force field. Without that magnetic shield, the sun's constant stream of radiation would have blasted our atmosphere away billions of years ago. So that hot, churning core is directly responsible for the air we're breathing right now.
Okay, so we've got these two incredible shields, the atmosphere on the outside and the magnetic field being generated from the inside. Exactly. So now let's zoom back up to the surface and talk about how our world is in constant motion. And I'm talking about everything, the oceans, the continents, even the climate itself. Well, the most basic movements are the ones we feel every single day. The Earth is constantly spinning, kind of like a top, and that's what gives us the cycle of day and night. And while it's spinning, it's also making that long journey around the sun each year. That orbit, plus the fact that our planet is tilted a little bit, is what gives us our seasons. Okay, so those are the big cosmic motions. But what about all the movement happening right here on the surface? I guess the most obvious one has to be water. It's everywhere, and it's always moving. Always. Water is constantly on the move in what we call the water cycle, and it's all powered by the sun. The sun's heat causes water to evaporate from oceans and lakes. That water vapor rises and cools down, forming clouds, and then eventually it falls back to Earth as rain or snow. It's like a giant circulatory system for the whole planet.
It's amazing enough that the water is moving all the time. But what's even harder to wrap your head around is the idea that the ground beneath our feet is moving too. It is, and that is all explained by one of the most important ideas in all of science, plate tectonics. The basic idea is that the Earth's hard outer shell isn't one solid piece. It's actually broken up into these enormous puzzle pieces, or plates, and they are slowly, very slowly, drifting around on top of that hot, flowing mantle we were talking about earlier. So these massive chunks of the crust are just sort of floating around. What happens when they move? What are the actual effects? Well, the effects literally build our world. As you can see here, when these plates crash into each other, they push up enormous mountain ranges. When they pull apart, new oceans can form. And all of that bumping and grinding is what triggers earthquakes and creates volcanoes. They are, in a very real sense, the architects of our planet.
Wow. So we've got all these different things happening. A hot core, a protective atmosphere, a water cycle, these huge moving plates. Exactly. So now we get to the most important part of the whole story. We're going to see how all these pieces connect to form one single living system, and what our role is in that story. This, right here, is the big reveal. This is the key takeaway. None of these systems works by itself. It all starts with the incredible heat coming from the planet's core. That heat makes the liquid outer core churn and move, which creates the magnetic field. And that magnetic field shields our atmosphere from being blown away by the sun. And that atmosphere keeps the planet at just the right temperature for liquid water to exist on the surface. And that water, on a surface that's constantly being reshaped by plate tectonics, creates the perfect stage for life to emerge and evolve. It's all one incredible connected machine.
That's a really powerful way to think about it. It's not a bunch of separate things, it's one giant system. But it also feels so huge, so abstract. So why does understanding all this deep geology and atmospheric science actually matter to us in our daily lives today?
It matters because this is our home, and this science is basically the planet's owner's manual. If we understand plate tectonics, we can better prepare for things like earthquakes and volcanoes. If we understand the water cycle, we can better manage our fresh water. And if we understand how the whole system works together, we can start to see our own impact on it. And hopefully, that means we can make better, smarter choices for the future. It's really just about learning how to be responsible tenants on this planet.
Exactly. And that brings us right back to where we started, with that image of the blue marble. The more we learn about it, the more we realize it's not just a big ball of rock and water, it's a single, deeply connected, and very precious home. And our chapter in that long, long story is being written right now. So I think this final thought says it best. The most important thing we can do is to keep wondering, keep asking questions, and keep caring for this beautiful blue marble that we get to call home.